Ladies and gentlemen, welcome to the Battle of the Ages. Four titans in the field of chemistry are here tonight to finally settle the long-winded debate of whose acid-base theory is the best. Each scientist will state their theories separately, and the audience will decide whose theory is best. Please give them a warm round of applause. First off, we have Savant Arrhenius. Next, we have Johannes Bronsted and Martin Lowry, who seem to have perfected the process of merging two people into one body, a marvelous feat indeed. And finally, we have Gilbert Lewis.
Even much better than us.
I know, right?
Now, let the battle begin.
The theory is simple. Acids produce hydrogen ions in solution, while bases produce hydronium ions. You don't have to worry about transfer of ions or protons. Like in other theories, this makes chemistry much easier for all to understand.
Alright, a big round of applause. For our next scientists, we have Bronsted Lowry.
My theory may be harder to understand than Arrhenius's, but my theory incorporates more acids and bases than his. My theory is that acids are hydrogen ion donors and bases are hydrogen ion acceptors.
And now, for our final scientist, we have Lewis.
Good evening, everyone. As you can see, we have had a lot of good insight into how acids and bases work. However, my theory incorporates the most substances compared to the others. I have concluded that acids are electron pair acceptors, while bases are electron pair donors. Although it is more tedious to calculate since each substance requires drawing a Lewis structure, I believe it is more beneficial for chemists to...
I'm sorry for interrupting, but you guys seem to know your stuff about acids and bases. I need some help with some heartburn. I was wondering what would be the best base to use in order to neutralize my stomach acid.
Well, you could try
milk
milk
carbonate. Hold on.
No, no, no!
Here, take this. It's antiacid. It should help.
Oh, thanks. Hopefully it works. Oh, I feel better. Thanks.
Don't mention it.
Hey, would you guys mind teaching your theories to my class?
Unfortunately, we can't.
But we know who can.
Yeah, we do.
So, what are acids and bases? Well, the theory that is most emphasized for us chemistry students is the Bronsted-Lowry theory, which states that acids are proton donors and bases are proton acceptors. This concept will be covered more deeply as we progress through the presentation. Acids are known for having a sour taste and for being corrosive to many materials.
A base is a molecule that is capable of receiving one or more protons. They are known to have a bitter taste and feel slippery to the touch.
Savant Arrhenius was a Swedish chemist that won the Nobel Peace Prize for Chemistry in 1903. He was the first to use basic principles of physical chemistry to calculate the extent to which atmospheric carbon dioxide will increase surface temperatures of the Earth through the greenhouse effect.
Gilbert N. Lewis was an American physicist and chemist known for the discovery of the covalent bond and his contributions to valence bond theory. Johannes Nicholas Bronsted was a Danish physical chemist known for his theory of proton donation and the work he did with Martin Lowry in the development of the Bronsted-Lowry acid-base theory. Thomas Martin Lowry was an English chemist who was awarded the Fellowship of the Royal Society for substantial contributions to the improvement of natural knowledge. This included fields such as mathematics, engineering science, and medical science.
Arrhenius acids are substances which produce hydrogen ions in solution. Arrhenius bases are substances which produce hydroxide ions in solution. Examples of Arrhenius acids are acetic acid, hydrochloric acid, hydrobromic acid, and hydrofluoric acid. Examples of Arrhenius bases are magnesium hydroxide, barium hydroxide, and sodium hydroxide.
Now, Lewis defined acids and bases, where an acid is an electron pair acceptor and a base is an electron pair donor. Some examples of Lewis acids would be sulfuric acid, phosphoric acid, and chloric acid. And some more examples of Lewis bases would be pyridine, benzene, and ammonia.
A Bronsted-Lowry acid is a proton donor, while a Bronsted-Lowry base is a proton acceptor. Here are some examples of how we would work out formulas for Bronsted-Lowry acids and bases. For the acid, we have hydrochloric acid, which donates a hydrogen ion to water to give chlorine and hydronium. For the base, we have ammonia, which accepts a hydrogen ion from water to give ammonium and hydroxide.
Acids and bases are commonly recognized as two separate states. However, some substances can have both acidic and basic properties. Water, for example, can act as both an acid or a base. The ability of water to do this makes it an amphoteric molecule. Water can act as an acid by donating its proton to the base and thus becoming its conjugate acid and hydroxide ion. It can also act as a base by accepting a proton from its acid to become its conjugate base, a hydronium ion.
There are some acids that can donate more than one hydrogen ion. These are called polyprotic acids. Carbonic acid contains two ionizable hydrogen atoms and is referred to as a diprotic acid. Phosphoric acid contains 3 hydrogen atoms it can donate and is referred to as a triprotic acid. As you may remember from our skit at the beginning, Dr. Lazarus needed some help with some heartburn. Here we will show you a demonstration of how exactly an antacid helps to neutralize the acids in the stomach to provide instant relief.
For this demo, we have an antacid in the form of a capsule reacting with a weak acid or rice vinegar. This reaction is to simulate the role of an acid in the human stomach. It takes a small amount of time for the acid to dissolve the plastic coating of the capsule, but eventually we see bubbles start to form, indicating the production of a gas. To understand the overall reaction in a better way, we are going to examine the chemical formula for this particular reaction. So, we have vinegar, or CH3COOH, plus antacid, which is mostly comprised of baking soda, or NaHCO3, reacting to form the final products of carbon dioxide, water, sodium ions, and acetate ions. As you can see from the reaction, not all of the baking soda is exposed to the vinegar at one time. This is to avoid the reaction happening too quickly in our stomachs.
To calculate Arrhenius bases, you have to remember that Arrhenius bases form hydroxide ions in solution. For example, sodium hydroxide dissociates into sodium ions and hydroxide ions in an aqueous solution. Lithium hydroxide dissociates into lithium ions and hydroxide ions in solution.
Alright, using what we learned from Arrhenius bases, can you tell me how the following compounds will dissolve in an aqueous solution?
Alright, here are the answers. Did you get them right?
Calculations for Arrhenius acids. Remember, Arrhenius acids dissociate to form hydrogen ions in solution. For example, hydrochloric acid dissociates to form chloride ions and hydrogen ions. Hydrobromic acid dissociates to form bromide ions and hydrogen ions. So now it's time to test yourselves. Looking at the acids provided here, could you write out how they would dissociate in water? Feel free to pause the video and try this on your own. Okay, so here are the answers. Hopefully you got them all right.
There are many acids and bases that you can find around the house. Some examples of common household acids include any citrus fruit, such as lemons and oranges, vinegar, soft drinks, and wine. Examples of common household bases include liquid drain cleaner, baking soda, soap, and bleach.
Alright, now let's test that knowledge. Can you tell me if any of the below items are acidic or basic?
Alright, here are the answers. Did you get them right?
We would like to do a brief overview of all the topics that we covered. At first, a definition of acids and bases was given, along with their physical properties. Afterwards, a brief history of each scientist that developed those theories was given, along with their theories. Examples of acids and bases that fell under those theories were also provided. The concepts of amphoterism and polyprotic species were covered, along with a demonstration of an acid-base reaction. Afterwards, sample calculations involving acid-base chemistry were demonstrated, as well as common household acids and bases.